In this video, I'll be covering the rest of Chapter 5 and the beginning of Chapter 6. We just went over multiplying polynomials, so now we're going to go over dividing polynomials. There is one shortcut when you're dividing monomials. Okay, when you're dividing monomials, basically what it's saying is you're taking every term from the numerator, the top, and you're dividing it by the denominator, the bottom. In this case, a plus b is divided by c. You can split that up as a divided by c plus b divided by c, and it is understood that c can never be 0, because if you divide a number by 0, you get an undefined or an error. So here's an example with numbers. You're going to take the 3a and you have to divide by each piece. So I'm going to split it up and I'm going to put negative 12a cubed divided by 3a and do the same for all the pieces below. And you keep the signs of the numerator. From there you do your math. If you're a's, we know that with math, when you're dividing exponents, one of the rules is you subtract your exponents. You subtract them together. And so I would take that a cubed and I would subtract 3 minus 1 because there's a single a on the bottom. And I get negative 4a squared and so on and so forth throughout. Okay. Using long division. Unfortunately for this one, there is no shortcut. You literally just need to do the process. So when you are dividing long division, when you are doing long division, there are 4 steps. The first one is to divide. Second step is to multiply. You subtract, and then you bring down any leftovers. In elementary school, when you would bring down, you would go until either it was completed or you would have a remainder. Here, I'll show you what we do in algebra. Okay, but as long as you cover these 4 steps, you will get the correct answer. So what you're going to do first is divide 7x into 28x squared. With this, whenever you're doing your division, you're only worried about your x. You don't need to worry about that plus 3. When you do your math, you know that it goes into 28x squared 4x times. Now you multiply 4x by both 7x and the positive 3. You do the math, and there you go. When you do your math, it is understood this is a subtraction problem, so you have to take that negative and you have to distribute it to each pieces. So to the negative 28x squared, and that 12x squared becomes a negative x squared, a negative x because you're distributing a negative. So from here, I get a 35x and I bring down my 15. Okay. I look at my x's again, so I figure out how many times can 7x go into a negative 35x. I get a negative 5. I multiply negative 5 by 7x plus 3, and I get my answer. From here, I subtract, and it zeroes out. There's nothing to bring down, so I'm done. My answer is 4x minus 5. Okay. In this problem, so you don't have to see every step, we'll just go through it again. Here again, we are looking at the x's, and so you take that 2x and you divide it by 4x squared. You get a 2x, you do your math, so you multiply, you subtract, you bring down the 8. You do the same process, you take the 2x and you divide it by a negative 20x, which is a negative 10. You multiply, you subtract, and you see that you have a 78 remainder, but there's nothing left to bring down. Now in algebra, we do not leave remainders. We have to turn our remainder into a fraction because we know there are 78 left of 2x plus 7. So our final answer will be 2x minus 10 because we already did the math on the top, plus a 78 over a 2x plus 7, and that would be your final answer. Negative exponents. This part is really easy. We like this one in class. So with negative exponents, your goal, you can never have a negative exponent, so you have to create a positive at all times. In order to create a positive, you basically just flip where your negative is. And if you watch the video on the slides that I give you at the beginning of the week, and the video we watched in class, you know the process of why we flip it from the numerator to the denominator or the denominator to the numerator. So for example, here we have a 3 to a negative 2. We can't have the negative 2. So all I do is flip it and make it a fraction. So it's 1 over 3 to the second power. And now I have a positive numerator, and I can work with that in the future, which means I can simplify and make it 1 over 9. With the x, it's the same process. I flip it. Now here, I can't make it smaller until I know what x is, so I'm finished. Okay, and this is your helpful hint for number 3. When you have a coefficient in the front and there is no parentheses with the 2 and the x, that means 2 is being multiplied by x to the negative 4. So 2 is hanging out by itself. Unless there's parentheses that tie them together, you can separate them. So what I do is I leave my 2 in the numerator and I flip my x to the 4th in the denominator. The quotient rule, as we know, is subtracting your exponents. When you subtract your exponents, if you do this and you get a negative 2, that means that you have an x to the 4th on top. So 4x is in your numerator, 6x is in your denominator, and you have to cancel out. In order to make that positive, because we cannot have negative exponents, it becomes a 1 over x squared. Okay. This is just basically saying it's vice versa. So like I said, if it's in the numerator, you have a to the negative n, you create a fraction and put it in the denominator. If it's in the denominator, you flip it and make it the numerator, and you can leave out the 1, unless of course the 1 is not a 1. So here we have 1 that's in the denominator. So then 1 over x to the negative 3. When we do this, we just flip the problem. Okay, so we're going to make that positive, which is an x to the 3rd over 1. Now I know the fractions look funny, especially on the bottom one. And if you're in class, I showed you the process, because when you divide fractions, you leave the first one, you multiply by the second one, but you have to invert it, so you have to flip it. So when you flip it and then do your math, multiply across, you get y to the 4th, x to the 2nd. So you literally flipped them and made them positive. Scientific notation. So when you're doing scientific notation, it's taking really big numbers or really small numbers and writing them in a simple form so you don't have a bunch of zeros. So the first one, you have to count so that your decimal has a value between 1 and 10. Okay. Then you count the number of spaces you moved, either positive or negative, and then you multiply, and everything is times 10 raised to an exponent. And this is what it looks like. So in this one, I have standard form in A, and I have to change the value into scientific form. So I have to move my decimal point, which is at the end, and make it so I have a value between 1 and 10. That is 4.7. So then I take that information and I get 4.7 times 10 to the 3rd, because I counted 3 spaces from the original decimal point to between the 4 and the 7. Okay, it is a positive number because your standard form is a larger number. In B, we count, you get a 4.7 again, but in this case, your original number, your standard form or standard notation, is a small number, so then you would have 4.7 times 10, to the negative 4. It's a negative because when we go back to our original number, we have to go to the left of the number line. Okay, standard form is the same process. So we go from scientific notation to standard form, and it's all counting. So when we have the first one, we have our scientific notation. We have to move the 10 3 spaces, and the numbers all count. Okay, so we take this information and we know that it's a positive 3, which means I'm moving to the right. I count 3 spaces, and my final answer is 5,273.8. With B, I know that I have a negative 5, which means I need to move to the left of the number line, so I'm moving to the left. In this case, the 6 is the only one in the way, but I have to move 5 times, so 6 counts as one move, and then I have to add 4 zeros. When you write this, you must write a 0 point, and then your 4 zeros, 6, 4, 5. And if you count from that decimal point and you try to get a number between 1 and 10, you will move your decimal point 5 times. Performing operations with scientific notation. Now in this class, we're basically only going to be multiplying in scientific notation. So what you do, just like we talked about over and over again, is you put your like terms together. So you have your coefficient, 7.3 times 8.1, and you have your scientific form, which is always times 10 to an exponent, so you put your exponents together. When you multiply exponents, you end up adding them together. So you get a positive 3, and there you go. When you're done, you go into standard form because that's what it asked us to do. It didn't ask us to just simplify. It asked us to go into standard form. We know we're going to move our decimal point 3 times to the right, and we have our answer. When we are dividing, which we will do occasionally, it's the same process. You take your like terms, so you have your coefficients, you have your exponents. In this case, we subtract. Okay, we subtract our information because we know that our quotient rule for exponents is subtract the numerator by the denominator and you get a -5. Now I know I was telling you in previous slides that negatives are not acceptable, but in scientific form they are because the negative tells us we're moving left on the number line, which gives us an extremely small number. I move my decimal point 5 times and I get my final answer. The latest is greatest common factor and grouping. We watched a video in class with greatest common factor and I felt like a lot of you got that. So I'm going to go straight into how to factor out using the greatest common factor. In this case, you have to figure out, of course, what is the greatest common factor for each term, and then you pull it aside. So here are a couple examples, and we will go from here. So when you look, you can take 3x out of 6x to the third, 9x squared, and 12x. So you take that 3x out of all and you pull that to the side. And if you notice here in the first one, I pulled my 3x over and then I bring down all my leftovers, and that is my polynomial simplified with or factored out from the greatest common factor. On the bottom, I can do the same thing, and I look, and I'm like, in each piece, I can take out a 7xy. I do my math based on my knowledge, and I pull that to the side, and that is factoring out based on greatest common factor. Here are some more examples. This is when you have more information, but if you look, I have an x plus 2 that are common with both. So in this case, I'm going to end up with 2 binomials. So I have 2 terms. I'm going to put my x plus 2 to the left, and I'm going to bring down all my leftovers. So a 6 minus y, and I know they're being multiplied because obviously in order to get the original problem, we would have to use either distribution or FOIL, and you would get your answer. On the bottom, on the bottom you have the same thing. We look and I'm like, both of them have a y plus 1 in each term, which means I can pull that aside and I combine the rest of my information. And that is factoring by the greatest common factor. Okay, so remember that factoring out the greatest common factor from terms of a polynomial should always be the first step in factoring a polynomial. So pull out what you can and make it smaller before you continue. Okay. Now in grouping, so in order to factor out by grouping, first we have to factor out the greatest common factor. If there are common binomials, you factor that out. If not, you rearrange the term and try to do these steps again. Okay, so for example, with this one, I know this is a lot of info, but I'm looking at what I can factor out, and I know in the first 2 terms, I can factor a 5x squared, and in the second 2 terms, I can factor out a 2. So I'm going to pull that information aside, as you notice here in my second step. I pull that information aside, and then I put my terms together, because now my 2 are the same. I have a 3x minus 2 in both terms. Okay, so I pull that aside and I put together my like terms and I have grouping. Okay, I have 2 binomials, which is what I want. Here's another example, just more of a vertical view of the steps. Same thing, I look at my first 2 terms, I look at my second 2 terms, I see what I can pull out. I combine my factoring, what I pulled out, and by that point your 2 should be the same. If it ends up that you cannot factor, then it's a prime factoring and it does not work. And I will show you more examples of that next week.